Okay, this one is a conceptual question. So here they have given that which of the following is or correct about CPU scheduling. Okay, fine. Option A, turnaround time includes waiting time. We know that turnaround time is completion time minus arrival time. There is one more formula also for turnaround time, that is burst time plus waiting time, right? So turnaround time is burst time plus waiting time. So see here, so for turnaround time we need waiting time, right? So turnaround time includes waiting time also. Yes. So option A is right. Then we move on to option B. The goal is only to maximize CPU utilization and minimize the throughput. So for CPU scheduling, is it minimizing the throughput or maximizing the throughput? So here the CPU utilization is maximization. This one is right. But do we minimize the throughput? If the CPU is utilized highly, the throughput is also increased, right? It should not be minimized. So option B is not the right option. Next, we go for option C. Round robin can be used even when the CPU time required by each of the process is not known a priori. Yes, only in SJF or SRTF we need the burst times, right? Or we need the CPU times before solving it. But for round robin, we need not know the CPU time a priori. So this option is also right. It's an MSQ question. So multiple options can be correct. Okay. Then the final option, implementing preemptive scheduling algorithm needs software. Yes. So the preemptive scheduling, you know, right? What a preemption is. Whenever you are executing a process, you can preempt the process and give the control of CPU to a new process, right? To execute. So this is known as preemption. But you have to keep this status of the process, right? In some memory, you have to keep this status of the process so that when it comes again, it has to resume from this point, right? So for that, there is a need for an hardware support. So this option is also right. So for A, C, and D is the right option. So this is an MSQ one. So here they have given 3 processes arrive at time 0 with CPU burst time of 16, 20, and 10 milliseconds if the scheduler has the prior knowledge about the length of the CPU burst time. The minimum achievable average waiting time. They are asking minimum waiting time, right? So minimum average waiting time for these 3 processes in a non-preemptive scheduler. Okay. And rounded off to nearest integer is dash milliseconds. So this one is asked in GATE 2021 set 1. It's a numerical answer type question. So let's see. So let's name the process as A, B, and C. There are 3 processes with arrival time, right? So they arrive at time 0. All the 3 processes arrive at time 0. The burst times of each of the processes are given as 16, 20, and 10 milliseconds. If the scheduler has the prior knowledge, so the scheduler before executing it, it knows the burst time. That means which algorithm it is. It can be either SJF or SRTF, right? Shortest job first or shortest remaining time first algorithm. And then they have given one more is right. It is a non-preemptive scheduler. And we know that SJF is non-preemptive scheduler and SRTF is a preemptive scheduler. So we'll ignore this and we'll take SJF, right? And SJF is not practically implementable because we have to know the CPU burst times initially before executing it. So SJF is kept as a benchmark for scheduling. Okay. So let's see, they are asking about the average waiting time, right, of this for SJF. So first we have to know what is the waiting time. So we'll draw the Gantt chart again. So at 0, right? So SJF means the criteria is burst time, right? Minimum burst time. Which has the minimum burst time, it will get scheduled. And the mode is non-preemption, right? So among these three, A, B, C, they arrive at 0, right? So we have to check which of the process has minimum burst time. Among A, B, C, C has the minimum burst time, right, of 10 seconds or 10 milliseconds. Okay, so we have to completely schedule it because it is a non-preemptive process. Okay, we have to completely schedule it. Then again, among these two, we have to check which one has the least burst time. Since all arrived at time 0, I am not keeping the constraint now in my mind about the arrival times because all the processes arrived in my ready queue. Now I have to concentrate only on the burst time. Okay, so next I'll schedule process A for 16 milliseconds. So my time now will become 26 milliseconds. After that, I'll schedule my process B, right, for 20 milliseconds. Okay, now I have to calculate the waiting time, right? Let's see. So see here, process C arrived at 0 and got scheduled from 0 itself. So it does not wait for any milliseconds. So my waiting time for process C is 0, right? Since it has arrived at 0 and I've started scheduling it from 0. Okay. Let's see for process A. Okay, it has arrived at 0 millisecond, but I have scheduled it at the 10th millisecond only. So it has waited in the ready queue for 10 milliseconds. Next, I'll see for process B. So process B has also arrived at the 0th millisecond, but I have scheduled it at the 26th millisecond, right? So it has waited for 26 milliseconds. Now I have got the waiting time of the individual processes, but they are asking the average waiting time, right? So average waiting time is 10 plus 26 plus 0 divided by 3. This will be my average waiting time of the SJF algorithm, right? So 36 divided by 3. So it is 12 milliseconds. So my answer will be 12 milliseconds here. Fine. Okay. So here they have given, consider the following set of process. Assume that they arrive at time 0. Consider the CPU scheduling algorithm as SJF again and round robin. So they have given two algorithms here. Assume that the process arrived in order, right? Because they have given arrived at time 0. So, and we have to know the order, right? So P1, P2, P3, P4 has arrived in this order. If the time quantum for round robin is 4 milliseconds, then the absolute value difference between the average turnaround time in SJF and RR round off to 2 decimal places. Okay, fine. So they are asking average turnaround time for SJF and round robin, right? Okay. So again, we have given 4 process P1, P2, P3, P4. The arrival time is at 0, 0, 0, 0, right? Arrived, all the processes arrived at time 0, and the burst times in milliseconds is given as 8724, right? So first we'll do SJF. Okay, for SJF, okay, first we'll do for SJF, right? So at time 0, all the processes arrived, so I'll schedule only P3 first because this one has the least burst time for 2 milliseconds. Then I'll schedule P4, right, for 4 milliseconds, so it becomes 6. Next, I'll schedule P2, right, for 7 milliseconds, which becomes 13. Next, I'll schedule process 1, right, for 8 milliseconds. So it becomes 21. Now, I'll calculate the completion time because we know that turnaround time formula is completion time minus arrival time. So I'll calculate the completion time of each of the process. Let's see, process 1 completes at 21 milliseconds, and then process 2 completes at 13 milliseconds. Process 3 completes at 2 milliseconds. Process 4 completes at 6 milliseconds. All these values are taken from this Gantt chart, right? For SJF, this is for SJF. Fine. Then I'll calculate the turnaround time for SJF. So the turnaround time is completion time minus arrival time, right? So 21 minus 0. So everything is 0, right? So I'll copy all the values of completion time as my arrival time. 21, 13, 2, 6. Okay. So this one I have to calculate the average turnaround time, right? Because they are asking the average turnaround time. So 21 plus 13 is 34, 40, 42. So 42 divided by 4 is 10.5. So my average turnaround time for SJF is 10.5. Fine. Now I have to do it for round robin also, right? Let's do it for round robin also. 8, 7, 2, 4. So for round robin, we have to maintain two queues. One is a ready queue, and then other one is the Gantt chart, right? Fine. So all the processes arrive at time 0. So all will be in my ready queue. P1, P2, P3, P4, right? Fine. So initially, I schedule P1. So what is the time quantum they have given? So the time quantum is 4 milliseconds, right? So I'll schedule 4 milliseconds for it. So again, it's not 0. I'll append it at the end of the ready queue. Then for P2, again, I'll schedule 4 milliseconds. Then again, I'll append it. Then for P3, right? So P3's burst time is 2 milliseconds only. So this one becomes 10. Here it becomes 0. Then I'll remove P3 from the ready queue. Next, I'll schedule P4 for 4 milliseconds, right? So it becomes 0, right? So I can remove it from the ready queue. Next, I'll go to P1 again, right? I'll schedule for 4 milliseconds. So now it becomes 0, right? P1 also. So I'll remove it. Then I'll do it for the last process, P2 for 3 milliseconds, right? So 21. Again, I'll calculate the completion time for round robin here. So completion time of P1 is 18 here. So you should not see 4. Okay. P1 does not complete here. P1 completes only here. It's a preemption, right? So P1 completes here only. So I have to take P1's completion time as 18 and not 4. Similarly, P2's completion time is 21. P3's completion time is 10. P4's completion time is 14. Okay. So one shortcut is for preemptive algorithms. You have to see it from the right hand side. Okay. For non-preemption, you can take it from the left hand side. So yes, so this one is a preemptive, right? So you see from the right hand side. So P2 completes at 21 millisecond. Yeah, 21. Next, P1 completes at 18 milliseconds. So 18. Next, where P3 gets completed, it completes here, right? So 10 milliseconds. Then P4 at 14 milliseconds. Now I calculate the turnaround time for round robin. So since my arrival time is again 0, right? So completion time minus arrival time is my turnaround time, right? So again, 18 minus 0 is 18, 21, 10, and 14. So again, I have to calculate the average turnaround time, right? So the average is 9, 13, so 3, and then 5, 6. So 63 by 4. So 15. It's 63 by 4 is 15.75, right? So this is my average turnaround time. Now they are asking what they are asking, the absolute differences, right? So absolute differences modulus of 10.5 minus 15.75. So it is 5.25. So my answer will be 5.25. Okay. I hope you understood this.